Hi everyone, welcome back to Dragonfly Engineering. So this week we've got an implement that I had to make to mold this plastic ring here, which was molded with 3 tunnel gates in the center circle of the part, as well as another part that's similar to this that had some challenges, but I really wanted to use tunnel gates due to the fact that you don't have to do any post work on a part if you do a tunnel gate. But the problem I was having is the tunnel gates were sticking in the mold after the ejection process occurred, and I couldn't get the parts to fall out in an automatic run. So I had to come up with something that I dubbed the SPRUE WACKER. So let's take a look at the SPRUE WACKER. So this is something I made on the fly, which effectively has like this stick here, which is in a pivot, and then this air cylinder basically will whack the sprue and knock it out of the mold. So this thing will bolt onto the side of a mold with this bracket right here. And after the part ejects and the sprue, which is in the middle of the circle, is stuck there and won't fall out, which means that the molding machine will close on that sprue and probably damage the mold. I quickly made the SPRUE WACKER, and this will whack the part or the sprue out of the mold and then get out of the way, and then the mold closes to mold the next part. So I'll show you how I made this thing, and we can also briefly go over what a tunnel gate is for some of you people who are not aware. So let's do it. Okay, so tunnel gate. If we have a injection molded part, which I'm going to make kind of a thick walled part here, just a cube, and this is going to be the solid plastic of the injection molded part, and your injection mold would have basically the profile around that creates the part itself. This would be one half of the mold, and then the other half of the mold would just, in our case, for simplicity, would just be a flat surface. Now, in a tunnel gate, what you wind up doing is well, for one thing, our part needs to have an ejector pin, so we can draw that guy in here, and we'll use a different color for the ejector pin. Of course, my green doesn't work. There we go. So that's the ejector pin, which will knock the part out of the mold. And then for our sprue, we're going to have basically a tapered hole in the mold on the A side where the plastic squirts through into a runner. And then on the B side of your mold, you wind up with a sprue hole as well, which I guess we'll just draw here. And then to eject your sprue out, you wind up putting a second ejector pin here. And then this goes to the ejector plate down at the bottom. That way when the mold opens, the sprue will be stuck, usually with little tiny undercuts that you can add so that the plastic stays. Now the trick with the tunneling gate is that you also draw a tunnel shape like this. So you don't have a parting line runner, but you actually create this triangular hole here. So the plastic will flow in and then fill your part subterranean of the parting line. So imagine all these flow lines, and then the plastic also fills in the rest of your sprue here. So when the A side of the mold pulls away, you wind up with no more A side, because that's on the other side of the molding machine. And your plastic part basically has a sprue like this. The second step is your ejector pin will then push forward, and this red portion of your mold creates a knife cut right here, and it will basically cut your sprue off from your part, and you'll have a little remnant sometimes on both sides. And then, so this occurs when the ejector plate and pins are pushing forward. So you wind up, after it's all said and done, you have your part that's ejected with a little remnant here. And then you've got a sprue with the remnant of the tunnel gate, like that. And it's two parts. And then your part is finished and ready to ship without having to do much of anything, unless you need to clean up the remnant or the little break point of your tunnel gate. So this, so to recap, a tunnel gate basically is a built-in knife in your mold. This sharp edge will cut your sprue and your part apart. Hi folks, this is post-editing Dave, and I did realize that I drew this a little too simple, this sprue with the tunnel gate. One thing that I didn't show is that you need to have a strain relief for the tunnel portion of your tunnel gate to actually pull out of the mold without being sheared off by your ejector pin. So the way I've drawn it here, we would have basically just cut the plastic right there and just had a plug of, or the sprue would have been sheared with the tunnel gate remaining in the mold. So to fix that, what we need to do is actually have a runner on the parting line to a certain degree to allow for a strain relief for this cone to pull out when the main sprue pulls out. So we'll erase some of this and we'll redraw a better tunnel gate. Now, maybe I won't exaggerate that much. But yeah, we got our tunnel portion here, and this is our little cutter section. And then we do want to have like a parting line runner to a certain degree. Which then goes into the sprue cavity. And then our ejector pin will be here. So the result is that our new sprue, the more working in the real space tunnel gate remnant, would have this flexure area and then the sprue itself. So what would happen is when this cone part of the tunnel gate is pulling out of the mold, it will actually flex down and be able to pull out the tunnel portion from the mold itself. Anyway, so yeah, the first time I drew it, it was oversimplified. This is a little closer. So make sure that you add this strain relief to your tunnel gate design. One disadvantage though is that these two parts in a simple mold will just fall into your finished parts bin, and you have to separate your part from your tunnel gate, which isn't a big deal. But for the sprue whacker, which we're going to show or talk about in this episode, you can actually have your part fall off into a bin, and then the second op would be that the sprue whacker would knock this sprue some other direction with basically a big stick. Again, I've got the wrong color. Some stick will come and just whack that thing off that way as your part falls into a bin this way. So that's kind of cool. Anyway, so that's a tunnel gate for those who didn't know. That's what I'm talking about. So yeah, as you saw in the video, I could basically just bolt this mold implement on any mold. So this is a separate mold, but if I had problems with parts sticking on the B side, I could just drill a couple of mounting holes and then mount this thing right here. Which works out pretty good. I did have a few issues with the SPRUE WACKER. One is that this stick, the actual whacking stick or staff itself, the first part that I made it out of was a Delrin rod, and that lasted maybe 500 whacks, and then it was so flexible that basically the stick effectively just broke off right here at the mounting hole in this rotating cylinder. So yeah, effectively when it would whack up, the stick broke and it flew all the way across the shop, completely over the roof, and then it landed onto the table all the way over here. So yeah, I couldn't figure out why the molding machine had stopped, because the part was closed and the mold protection kicked in and the machine said, I can't do it. And the stick was missing, and I found it. It flung way over and then landed basically right there on the table. So like 15 feet away. So anyway, that was an issue. And then the other problem I ran into, you can probably see a little bit of a problem right here with the stick itself. But yeah, you can see how there's a chunk missing out of the side of it. And that happened basically because the stick tried to come back up, and I probably had low air pressure or something, and it got essentially just chopped off by the guide pin and bushing on the mold. But I went and no, actually I think this one completely broke off. So it got chopped and then it broke here, because you can kind of see how there's a broken chunk here on the end of the stick. So those were some issues that I experienced, but all in all, the thing worked great. I mean, it was several thousand cycles of clearing the sprue. Sierra, what's up? Where's that squirrel? Or is it a kitty cat?